In this tutorial, I'll show you how you can create animations with hand tracking and face tracking from video files through DeepMotion Animate 3D, and how to retarget them to metahumans in Unreal Engine 5. I want to thank DeepMotion for reaching out to me for the second time and sponsoring the creation of this tutorial video. Their service Animate 3D allows you to create animations from video files you found on the internet or captured with your own camera through their AI-powered motion capture technology. They have a generous free plan that gives you 30 animation credits each month. Let's create a new project. Select the third-person template and make it a blueprint project. Input a name and click on Create. We'll start out by importing a metahuman into the project. Click on Window and then Quixel Bridge. Click on the icon of a human on the left. This will open the metahuman presets. You can also use a custom metahuman character for this project, but if you don't have much experience with metahumans, I recommend using a preset first. As a beginner, you also shouldn't pick a character with advanced grooms, which can cause issues, so I recommend you pick the same character as me to follow along for the first time. I'll go with Ada, whom I already downloaded the assets for. If you haven't downloaded this character already, you will most likely be asked to sign in, so please go ahead and do that. Then click on Download. Since these are really high quality assets, the download might take a while. Once your metahuman finishes downloading, click on the Add button. Your Unreal Engine project should now become the active window again and show you some messages about missing plugins which the metahuman depends upon. Just click on Enable Missing for all the prompts that show up. You should then get a prompt asking you to restart the project. Click on Restart Now. You might be asked to save some project files, in that case click on Save Selected. Once the project restarted, open up the content drawer. You should see a folder called Metahumans. Open it up, navigate to Ada and then find BP_Ada. Drag this blueprint somewhere into your level. Your PC might freeze for a few seconds and you might have to wait for shaders to compile. Our metahuman is now ready, so let's head over to the DeepMotion website to generate some animations. You will first need to create a free account to be able to access Animate 3D. After that, head to the dashboard and click on Create. We want to create a 3D animation, so leave this as the default. Scroll down to check out the capture guidelines. Whether you found your video clip on the internet or captured it yourself, you want to make sure it's in line with these guidelines to get the best result for your animation. You can also check out the official demo video for a more detailed explanation of these guidelines. For the first animation, I want to use a clip of a person with a full body shown and moving, since we want to use this for our body and finger animations. Once you've found a good clip, simply drag it onto the panel and wait for it to be analyzed. There are a few settings here which we want to take a look at. FBX output is enabled by default and should stay that way. Root joint at origin is a setting they specifically added for Unreal Engine compatibility, so let's enable it. Let's also enable hand tracking, since we want the fingers to be animated for this animation. Physics filter can often help you avoid clipping and make the animations look more natural, so I'll enable it for this clip. And lastly, I want to enable face tracking to show you how easy it is to get simple facial expressions working with your metahuman. However, full body clips only allow for simple face tracking and no eye movement. This is something we'll tackle later with another clip. Click on Create and wait for the animation to be processed. You can then check out the result here. Download the file to your PC. Right-click on the archive and unzip it. There should be two files, but we only care about the one without T-pose in the name. You might want to rename it to something that's easier to work with. Back in Unreal Engine, create a new folder for your animation. Drag the animation file into the content drawer. Make sure that skeletal mesh and import mesh are checked. The skeleton should be none, since Unreal will generate this for us. Also make sure that import animation is checked. And also import bone tracks. Lastly, open up the Advanced tab and check Import Morph Targets. You might get a few warnings about bone names clashing or smoothing groups, but these aren't relevant. If you're using Unreal Engine 5.0.3 or higher, you might run into some issues here and get this error message. In that case, you can check out the separate video with an explanation of the bug and a workaround. You should now have a few new files in your content drawer. Look for the animation sequence file. In my case, it's called walk and wave_anim. You can see that the animation is already working correctly with fingers and facial movement on the DeepMotion mannequin. The curves you can see below are the morph targets or blend spaces for facial animations. If you aren't familiar with morph targets, I'll leave a few links in the description that explain the concept, since we'll be working a lot with these during this tutorial. We now want to retarget this animation to our Metahuman. The first thing we need to do is create an IK rig asset for our Animate 3D skeleton. An IK rig will allow us to perform pose editing on a skeletal mesh. Right-click in the content drawer, hover over animation and click on IK rig. Then select our Animate 3D skeletal mesh. In my case it's called Walk and Wave. Let's name it IK_Animate 3D. Double click to open it up. The way we retarget animations now is quite different from Unreal Engine 4. We now don't need to match a bone from one skeleton to another, but rather match bone chains which we create for each major limb. Let's start by setting the retarget root. The retarget root generally needs to be in the pelvis area. In our case that bone is called hips. Right click it and set retarget root. Let's add the first bone chain for our spine. We can select multiple bones by clicking on the first one, holding shift and then clicking on the last one we want to select. Select spine, spine 1, spine 2 and then right click. Then click on new retarget chain from selected bones and write spine as the name. Create another chain just for the neck by itself. Then another chain just for the head. Let's move on to the left arm. We don't want to include the left shoulder bone, so ignore it. Select the left upper arm, forearm and hand. Right click and create another chain. Name it arm left. Then do the same thing for the right arm. Select the right upper arm, forearm and hand and create another chain. Name it arm right. Scroll down to the legs. Select the left up leg, leg and foot and create a new chain. Call it leg left. Then select the right up leg, leg and foot bone and create a new chain, call it leg right. Then lastly select the root and create a chain for that bone by itself. Now we want to double check that we haven't made any mistakes. It can very easily happen that you mixed up a left bone with the right bone, so make sure to check that your chains exactly match the ones you can see on my screen. We then need to repeat the process for our Metahuman. Navigate to the Metahumans folder. Create an IK rig for the Metahuman. For the skeleton, just type in the name of your Metahuman and you should have a choice between the face and the body. In Ada's case, the body is called what you can see on the screen right now. This is short for female medium normal weight body. Now we want to do the same thing we did for our Animate 3D skeleton and set up the same bone chains. Right click the pelvis and set it as the retarget root. Then select all the spine bones and create a new chain. In this case there are 5 instead of the 3 bones our other character had, but that's not an issue. Create a new chain for the 2 neck bones. Then a chain for the head by itself. The arms are a bit more complicated here and have a few bones we don't need to select. Only select upper arm _L, lower arm _L and hand _L. You can add single items to your selection by holding Ctrl when clicking on the next bone. Scroll down until you find upper arm _R, select it, and lower arm _R and hand _R to create a new chain. Scroll down all the way to thigh _R, also select calf _R and foot _R as well to create the chain for leg right. Then select thigh _L, calf _L and foot _L for the leg left bone chain. Lastly, create a chain for the root by itself. Double check that you didn't make any mistakes and your setup looks the same as mine. Go back to the folder for your Animate 3D animation and right click. Go to Animation and select IK Retargeter. The asset to copy animations from should be IK_Animate3D or whatever you call the IK asset for the Animate3D character. The target IK rig asset should be IK Metahuman, which we just created. For the skeleton preview, search for f_met_nrw_body. There might be two assets with this name and we want the one with the gray body from the common folder. We now need to match the poses of the skeletons. Click on New Pose and call it T-Pose. Then click on Edit Pose. Look for the bone draw size and lower the value until it's easier to recognize the bones. We then need to move the arm up, but with the current snap settings we can't hit the exact value we want. Set the rotation snap size to 5 degrees. Now we can move it up by exactly 55 degrees and then do the same thing for the other arm. Move the camera to view the character from the top. Rotate the lower arm bones by 30 degrees to match the DeepMotion mannequin. Double click on the animation to play it and don't forget to exit the post editing mode. Let's export this animation to see it on the actual Metahuman. Click on Export Animation, go to the Metahumans folder and create a new folder for the retargeted animations. Save the animation here. In the animation file you can see that the morph target curves have also been saved in this asset properly. Look for BP_ADA in the world and select it. In the details panel select the skeletal mesh of the body. For the anim to play we can now select our retargeted animation to check it out on the Metahuman. Change the play mode to simulate so we can have full control of the camera. You can see that the body animations have been successfully retargeted and the simple facial movement is also working. However, the fingers aren't moving yet, so let's get into that. Go back into the IK asset of the Animate 3D character. For setting up the finger chains, we can have a look at the IK asset for the third person mannequin and use it as a reference for the naming conventions. Let's do the left thumb first, so select thumb 1, thumb 2 and thumb 3 and create the left thumb chain. Select index 1, index 2 and index 3 to create the left index chain. Select middle 1, middle 2 and middle 3 to create the left middle chain. Select ring 1, ring 2 and ring 3 to create the left ring chain. Select pinky 1, pinky 2 and pinky 3 to create the left pinky chain. Now let's do the same thing for the right hand. Select thumb 1, thumb 2 and thumb 3 to create the right thumb chain. Select index 1, index 2 and index 3 to create the right index chain. Select middle 1, middle 2 and middle 3 to create the right middle chain. Select ring 1, ring 2 and ring 3 to create the right ring chain. Select pinky 1, pinky 2 and pinky 3 to create the right pinky chain. Now we need to go through the same process on the Metahuman, so open up IK_Metahuman. You can see the finger bones here are a bit more complicated and also have parts we don't care about. We always only want to get the 3 main bones. For the Metahuman, we'll start out with the left pinky. Select pinky 1, pinky 2 and pinky 3 and create the left pinky chain. We can then collapse the pinky so we don't have to scroll as much. Select ring 1, ring 2 and ring 3 to create the left ring chain. Select thumb 1, thumb 2 and thumb 3 and create the left thumb chain. Select middle 1, middle 2 and middle 3 and create the left middle chain. Select index 1, index 2 and index 3 and create the left index chain. Let's do the same thing for the right hand. Select pinky 1, pinky 2 and pinky 3 and create the right pinky chain. Select ring 1, ring 2 and ring 3 and create the right ring chain. Select thumb 1, thumb 2 and thumb 3 and create the right thumb chain. Select middle 1, middle 2 and middle 3 and create the right middle chain. Select index 1, index 2 and index 3 to create the right index chain. Let's go to our IK Retarget asset. If the animation is still playing, save everything, close it down and open it up again. Play the animation again and then clear the target IK rig asset to reset it and select IK_Metahuman again. If you play the animation now, you can see that the finger animations are already working to some extent. However, we can improve this a bit. Go back into edit mode and make the draw bone size even smaller. Just like we did for the body, we now want to match the pose for the finger bones to the Animate 3D mannequin. For the fingers, there isn't really a scientific way to go about it and you don't have to worry about setting the exact angles I'm using. It doesn't have to be perfect and will work out even if it's close enough. We mostly want to worry about straightening out the fingers. After you're done matching the bones, leave edit mode and look at the animation again. If it doesn't look quite right, you can go back into edit mode and make a few adjustments. Usually the thumbs are the hardest part to get just right, so you might need to pay some extra attention to them. Now the tracking is looking great. We now want to export this animation file with the fingers working. Sometimes I could complete the step without issues, and sometimes I would get a crash with the assertion failed OutPose.IsNormalized error. This is an issue that can happen when setting the pose for fingers. So if you keep on getting this crash, you might want to create a new pose and try again. Set up the rotation for the arms again first, but this time for the fingers try to change as little as possible while still getting a good result and take things slowly. You should then be able to export the animation. Rename it to make it clear that this is the one with fingers working. Now select the blueprint for Ada in the level again and set this animation to the body as the animation to play. We now have an animation with all the major body parts, the fingers and simple facial animations working. However, to get advanced facial animations and eye movement working, we'll have to create another animation from a clip that is better suited and use it on the face only. Go back to the Animate 3D dashboard and create a new job. You want to select a clip that has very clear facial movement and some eye movement. We'll need to tweak some settings to get the best result for facial animations. Enable root joint at origin again for Unreal Engine compatibility. Also enable face tracking. Enable upper body only. And lastly, adjust the eye tracking sensitivity. This is a new setting that has recently been added, which allows us to adjust the eye movement to our liking. I'll select 1.0 for this clip. Again, wait for the animation to be processed. You can now see the result here. Download the file. Unpack the archive and open the folder. Again, we only care about the file which doesn't have T-pose in the name. Rename it to something that's easier to work with. Back in Unreal Engine, create a new folder for this animation and drag it into the content drawer. The import settings should be the same as last time with one exception. For skeleton, we want to reuse the skeleton from the walk and wave animation. This way we don't have to create a new IK asset and make many things easier for us. Again, you might encounter the FBX import bug again here, so follow the video in the description if you're having any issues. After everything was imported, open the animation file and you can see the facial movement and eye movement is being displayed correctly on the Animate 3D mannequin. We now want to retarget these to the face of our metahuman. Open up the IK file for the Animate 3D character again. Look for I_L and create a bone chain for left eye. Then select I_R and create a bone chain for right eye. Go to the Metahuman folder and right-click to create a new asset. Go to Animations and IK rig. Select the face mesh of our metahuman. We now need to find the eye bones of the metahuman, but it's really hard to locate them on a character with this many facial bones. In this case, it's easier to just go to the bottom right and add a new chain here. Call it left eye. For start bone, we can then start searching for L_I and select facial_L_I. And then select the same bone for end bone. Then create a chain for right eye. For start bone, search for facial_R_I. And then again the same for end bone. Go into the folder of the walk and wave animation and create a new IK retargeter. The asset to copy animations from should be IK_Animate3D or whatever you call the IK asset for the Animate 3D character. For the target IK rig asset, select the IK rig of the metahuman's face. Even though the facial animations and eye movement doesn't show up in this preview, it's not an issue. Simply select the facial animation asset and click on Export. Save it in the Metahuman's Retargeted Animations folder. Again, even if you look at the animation here, it's not playing on the metahuman's face, but you can see that the morph target curves have been correctly brought over. We actually depend on an animation blueprint to get this working. Go to the Metahumans folder, Common and Face. Open up face_anim_bp. Then open up the anim graph. This is where the magic happens. The ARKit mapping pose is what enables our retargeted blend spaces to work and is the reason the animation won't show up properly by itself, but works when we run it through the animation blueprint. This node copies the animation from the body and applies it to the face, and is the reason it was so easy for us to play the walking animation with facial features enabled. But now we want to play a separate animation on the face and don't need this anymore. Create a new state machine and connect it here instead. Add a state and call it idle. Drag off from this node and search for play and the name of your retargeted facial animation. When we compile and save, we can see that the advanced facial animations are now playing on the Metahuman. On the map we can also confirm this, and we are now successfully playing one animation for the body and fingers and a separate animation on the face. However, the eye movement is still not working, and the last thing we'll need to set up. The eyes for the Metahuman are actually a bit special, and it seems like they're controlled by many different factors. Just to demonstrate this, if you try to rotate the eye bone of a Metahuman, it won't work out, while you can freely move the eye of any other character. I believe one of the reasons for this is the animation post-processing. Go into the Metahuman's ADA folder and open up the Metahuman blueprint. Select the skeletal mesh for the face. When we check Disable Post-Process Blueprint, you can see that the eye movement is now being applied. The angle is still a bit off, but that is something we'll fix in a later step. Also, the facial movement stops when we check this option. This puts us in quite the conundrum, because we need to disable post-processing for the eyes to work, but we need to enable it for the facial animations to work. Now, I tried many different ways to get around this issue, but the only thing that ended up working is a bit hacky, and a better solution might become available as we get to know more about the Metahumans over the following months and years. On the face, remove the checkmark from Disable Post-Processing again and make sure the facial animations are playing. Then duplicate the face skeletal mesh. Call it Eyes. Here you want to check Disable Post-Processing so that only the eye movement is playing. We want to hide the parts we don't need on these meshes. Open the content drawer and create a new folder for materials. Right-click to create a new material and call it m_hidden. Set blend mode to masked and shading model to unlit. Hold the 1 key and then click anywhere. Connect this node to opacity mask and save. We've now created an invisible material. Back in the Metahuman blueprint, select the face skeletal mesh. When scrolling down in the details panel, you can see all the different materials the face is using. Element 3 and 4 are the material for the eyes. Make sure your m_hidden is selected in the content drawer. Then on element 3 and 4, click on the left arrow icon, which will apply the currently selected material from the content drawer. Then go to the skeletal mesh called Eyes and do the exact opposite. Apply the hidden material to everything except the eyes, which are element 3 and 4. Now we can see the facial movement and eye movement working in unison. When looking at the Metahuman in the level, we can see that it also works together with the body animation. There is one thing left we can do to improve the quality of the facial animations a little bit. On the blueprint of Ada, go to the body and clear the animation so we can get a better look at the face. This animation is looking pretty clean, but there might be a few artifacts or exaggerated movement depending on what kind of animation you used. Open up the retargeted facial animation sequence for the Metahuman. Click on one of the curves and press Ctrl+A to select them all. Right-click and edit selected curves. Here you can see all the keyframes for a facial animation, which we can clean up a little bit. Click in this panel and then again press Ctrl+A to select all the keys. Right-click and select Filter. We want to use the Simplify filter. The higher the value for tolerance is, the more keyframes will be deleted. You can try some different values here, but for my animation 0.025 was about right. I was able to reduce the amount of keyframes from 15,000 to about 650. We now made the animation easier to work with and a bit more stable without losing any important information. If your animation is still a bit jittery, you can also select keyframes of unstable areas and apply a Simplify filter again with a higher value. Finding these areas might be easier when looking at a single curve instead of all of them. If you're still not satisfied with the result, you can also manually delete some keyframes that are causing jittering by selecting them and pressing delete. Check out the result every once in a while in the level and repeat this process until you're happy with the result. Lastly, let's take care of the eye rotation by adding an offset. Open up the animation blueprint for the Metahuman's face again. and go to the animation graph. Here go all the way to the right where you can see the output pose and the component to local node. Move both of these to the right to open up some space. Add another transform modify bone node here. For the bone to modify, first select facial _L _ I for the left eye. We only care about the rotation, so scroll down. Rotation mode should be add to existing, since we simply want to add a slight offset on top of our animation that is playing. We want to change the rotation on the x-axis by about 12 degrees to bring the eyes down a bit. In your case, this number might be slightly different. Then compile and save. Back in the map you can see that the angle is now fixed for the left eye only, and also works properly together with the animation when it's playing. Go back into the animation blueprint for the face one last time. Duplicate this node and connect the pins. With this new node selected, go to bone to modify. This time select facial _R _ I for the right eye. Double check that the rotation value is the same. Don't forget to compile and save. Now you can see that both eyes are fixed. Apply the walking animation to the body again, and then you can see how everything is working together in unison. I hope you can now build something awesome with your newly acquired knowledge. See you in the next video.